So now the recording has started. So let us take a new problem for the frame analysis. That too, in which method we will do? We will do the moment distribution method. So let me check my notes. I will take a problem from there. Yeah, got this one. So please, all of you, please take down the problem. Analyze the given frame. Even I'm writing that one. Analyze the given frame by moment distribution method full stop. Also draw the shear force and bending moment diagram. Okay, so the frame is somewhat like this. This is fixed. This is A. This is C. This one is again fixed. This is V. Okay, so here anything else is there? No. So now it is time for the loading. So here we have a load of 100 kilonewton. Next we have a UDL of 20 kilonewton per meter, and this is 3 meters. This is 2 meters, and this one is 3 meters. This is I, and this one is also 3 meters. This is also I, and this one is having 2I. This one is having 2I. Okay, so analyze the frame by moment distribution method. So if you go to the solution, what will be the first procedure? What will be the first step?
Fixed end movements.
So step 1, fixed end moments. Okay, so what will be MFAB? MFAB how much? Hmm? MFAB equals to minus 100 into 3 into 2 square by 5 square, is it? Is it? Then
Yes, sir.
so please mute your mics. Suddenly some voices are coming. So how much it is coming? MFAB
Minus 48 kilonewton meter.
8 kilonewton meter. Okay. So MFBA MFBA equals to how much is MFBA? Again 100 into 3 square into 2 divided by 5 square. How much it is coming? MFBA
72.
kilonewton meter. Next one MFVD equals to MFDB equals to 0. Next, because here there is no load in this one. Okay, directly laterally the no load is there. Next, MFBC equals to minus 20 into WL square by what will be the formula?
WL square by 12.
MFCB equals to 20 into 3 square divided by 12. Okay, so how much it is coming?
Minus 15 kilonewton meter.
Meter, and this is plus 15 kilonewton meter. Okay. Now, so we have determined all the fixed end moments. Now, what will be the next step? The next step will be
Distribution table.
if structure. Okay, here this is the main joint. Okay, let me highlight that one. This one is the main joint where the three members are connected. This is the main joint, and these are the supports, okay, or supporting joints. So and A is fixed, and D is fixed, and C is fixed. Okay, so for fixed ends, what will be the distribution factor? For fixed ends,
0.
what? 0.
Sir, C is free end, no, sir.
C is
Simply supported, no, sir.
yes. So for let me take step 2. Step 2. distribution factors. Okay, so for support A, D, the distribution factor, sorry, distribution factor equals to 0. For support, this is D actually. For C, the distribution factor is equals to 1. Okay, so now we will go for the distribution table. So all of you please refer your diagram. Okay, so let me write joint, then members, then we have what will be the next one? Member stiffness. Next one will be total stiffness. And the next one will be distribution factor. Okay, so we have the joint B. So in joint B, we have again 3 members that are being connected. So it is joint members BA, BC, and BD. Now, regarding the member stiffness, let us see what will be the value for member stiffness. Then we will have the value for distribution factors. Okay, let me. So see this one. Hmm. Yes, so let me make this magenta. Okay, now this joint B. If we take joint B, this is joint A is fixed, joint D is fixed, and joint C is hinged. Okay, so what will be the formula for stiffness, element stiffness for A? It will be since this is the near end, the far end is fixed. If the far end is fixed, what will be the formula? What is the formula for member stiffness?
4 EI by L, sir.
4 EI by L. If it is hinged, then
3 EI by L.
3 EI by L. Okay. So the same thing we will use for calculating the distribution factor and the member stiffness. Okay. So BA. So if you consider BA, it will be 4 EI by 4 EI by L. Okay. If it is 4 EI by L, then 4 into EI is for BA, it is 4 into 3I, 2I, right? 4 into 2I into E by how much is length? Length is 5 meters. 5. Okay. So it is 8 by 5 EI. Okay. So similarly for BC, it is 4 EI divided by, this is I, this is L. So it is 4 into this one is again I. So 4 same 4 EI divided by L is 3 meters.
Sir, for PC, he is simply supported, sir.
Okay, sorry,
You have
sorry,
to
sorry, 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 sorry. I'm yeah, this is for BD. Okay, so this is wait, let me erase this one. Right, this is for okay for BC. It is sorry. 3 EI by L. So 3 EI means 3 into this is also I. So 3 EI divided by L is how much? Again 3 meters. So it is EI. And for BD, it is 4 EI by L is 3 meters again. L, so 4 by 3 EI. Okay. So what will be the total stiffness? Total stiffness will be 8 by 5 plus 1 plus 4 by 3 EI. So please calculate how much it is coming. Total stiffness is 8 by 5 plus 1 plus
3.93. 3.93.
3.93 EI. Okay. So the distribution factor will be summation, sorry, K by summation K. This is K. This is K and this is, sorry, this is summation K. So this one will be K by, array yaar. K by summation K. So please calculate how much will be this one.
0.4, sir. 0.4.
0.4. How much will be this one?
0.25.
0.5.
0.33.
0.33.
33.
58 it is coming. Okay. So let us take all these values. Okay. So now we have calculated the distribution factor. So now what will be the third step? What will be the third step?
Distribution. Moment distribution table.
Moment distribution table. So step 3. Wait, 1 minute, guys. I will unshare this one and again share because it is getting hanged in between. Now I think it will be working fine. Step 3 is moment distribution table. Okay. So so the first one will be joint okay, so joint A, B, C, and D. Okay, let's say this one. So next one is member. So it is AB. So the first one is AB, then BA, BA, then what will be the next one? BC, then BD, then CB, then any others?
DB.
DB. Okay. Now DFS, distribution factors. Okay. So for AB, what will be the distribution factor? What will be the
0, sir.
0? Okay. 0. Then distribution factor for BA it is 0.41, right? 0.41 or 0.4? Oh, no, sorry, 0.40 or 0.4. Okay. Next, this is 0.25 distribution factor. This is 0.338 BA, BC, BT. Okay. Then the distribution factor for CB will be, what will be the distribution factor for CB?
1.
And the distribution factor for DB?
0.
0. Okay. Next one is the fixed end moments. Fixed end moments. Okay. Fixed end moment for AB it is
minus 48.
minus 48. Then what is the fixed end
BA
moment?
72
Yes. Next one.
minus 15
Minus 15
Yes.
plus
Next.
15.
0.
0. Then
That will be the
BC,
CB
BD
50.
plus 15 and
right?
0.
Okay. Now the next step will be balancing. Balancing. Now, please, all of you do your calculations. Okay. So for balancing, balancing, since the degree of DF is 0 for AB, no doubt for the balancing moment is plus 48. But this one is 0. The distribution factor is 0. So this one will be 0, right? Okay. Next one will be minus 72. Minus 72 plus minus 72 plus 15 plus 0. Okay. So minus 72 plus 15, how much it is? CAL calculator. Minus 72 plus 15, it is minus 57. So minus 57 is means plus 57. So 57 into 0 0.4, it is 22.8. Then this one will be 57 into 0.25, 14.25. Then this is 57 into 0.338. So this is 19.22, sorry, 266. 19.66. Then CB. CB will be, the balancing will be, since it is 15, so balancing moment will be minus 15 and into DF is 1, so it is minus 15 and this will be 0. Okay, now after balancing we have the carryover factor. Okay, so carryover factor or COM, carryover moment, whatever you may call it. Okay, so now please mute your mics.
ఈ మధ్యన చాలా ఏడుసా గారి నా పిల్లలు ఇష్టం రా అందుకే కొట్టలే.
Please mute your mics, guys.
Hey, Jagan.
Okay, next one is carryover moment. Okay, so if you see, this is A, this is B, this is D. Okay, so AB, any moment? No, it is not there. So BA, some moment is there. So this BA will transfer to AB. Why? Because AB is, or this end A is fixed. Okay, so BA, it will transfer some moment to AB, and how much will be that moment? That moment will be half of 23.37, right? Okay, wait. This is 72 plus minus 15. It is 57. So this will be minus. This will be again minus. This will be again minus. So this one will come as minus 11.685. Okay, and next one. So if we talk about this now BA, yes.
22.8 divided by 2 is 11.4 only, sir.
11.4. 11.4. Okay, 11.4. Then this one will be minus 7 point. So BC, it will go to, so if we are applying something at BC, it will go to CB, but the CB, for CB it is, the far end is simply supported, so nothing will come here, right? Nothing will come here. Let me erase this one, then I will tell you. This I should not write directly. So let me put So BC will go to CB and BD will go to DB. Both will be highlighted. Okay. Now, next, what will be this value? This will be, any value will be here. Please tell.
No value is there.
No values.
Yes, sir. No values.
Okay. What about this one?
BC. CB have no value. No, that's why BC have already have value.
No, BC is having 15, right? If BC is having 15, then half of it will come. BC is having value. Sorry, CB is having value. Okay, so CB value will definitely come here. Okay, so that's why. So whatever is there in BC, it will go to CB, and whatever is there in CB, it will come here. Okay, so since from B to C it cannot go because of this simply supported end or hinged end, and but from C to B it will definitely come. Okay, so this will be minus 15 by 2 equals to minus 7.5. This will be minus 7.5, and rest all I agree that they are 0. But what about this one? This this from B to D. Yes, definitely it will come because it is a fixed end. Okay, so this will be, it will be like this, minus 19.266 divided by 2. So it is coming, how much it is coming? Please calculate.
Minus 9.633.
Minus 9.633. Now after this carryover moment, next will be again balancing, right? So again balancing. Okay, so now we can see here we have only minus 7.5. So minus 7.5 means plus 7.5 it will come. Okay, so plus 7.5 into 4. So 7.5 into 0.4, it is 3. Then 7.5 into 0.25, it is 1.875. Then 7.5 into 0.338, it is 2.535. Okay, now this one will be 0, this one will be again 0. Why? Because the DF is 0. Okay, similarly this one will be again 0. Next one will be again carryover moment or carryover factor, whatever you may write. Okay, so this one will come here and it will be 1.5. Then nothing will be here. Then this is 0 and this is 1. 275 because this one will come here with 2.35 divided by 2, 1.26, 1.2675, 1.2675. Okay, so next one will be again balancing. Then this one will be 0. Here nothing is there. Here also nothing. That too, this one will be 0. So this gives us final n moments. Okay, so please calculate the final n moments, that is minus 48, minus 48, minus 11.4, plus 1.5. How much is that one? Please tell me these values. This one, 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 next this one, then this one, everything. This will be 0. So if I am not mistaken, this is minus 8.415. Please correct me if I am wrong. Minus 11.63. Sorry, not 11.63. It is minus 16.83. This is minus 34.875. This is 51.705, and this one is minus 58.1475. Please calculate these values and tell me if it is correct or not. Anyone, please guide me with this one. If these values are correct or wrong. This is 34 point something. 34.8.
Sir, AB is minus 54.90.
AB is
minus 54.90.
minus 54.90. Okay, next one.
57.9.
This is 57 point.
No, sir. AB is 57.9, sir. I calculated once. 57.9, sir. AB.
Okay, any others? Yeah, please tell me the values. 57.9. It is. Govardhan is saying 57.9.
Yes, sir.
Okay, next. What is the next value? Is it correct? 51.705.
Yes. Next one 52.20, sir. 52.20.
So this has made some mistakes. Next one.
34.875. Minus 34.875.
This is minus
Okay, sir. It's
34.875.
okay.
Yeah, okay. Next one, minus 16.83. Please calculate and tell.
731, sir. Minus 16.731.
This is minus 16. Minus 16.731. This is 0. This is minus 8.415. Is it correct? Minus 8.415.
Minus 8.36, sir.
Minus
Minus 8.3655.
okay. Minus 8.6. 3655. Okay. So now we have got the final n moments. Okay. So let us, what will be the next step?
Reactions, sir.
Reactions. Okay. So let us find the reactions. Step 4. Reactions. So this one, this is the structure again. I'm drawing it here. I'm just drawing a rough diagram. Just for for visualizing and all. So this is A, this is B, this is C, this is D. And so let us take a span AB. Okay, so if we take the span AB, if we draw the free body diagram for this one, so let us say this is A, this is B. So one support reaction will be here. Okay, MAB. MAB, it is coming as 57.9. Okay, so it is 57.9. Similarly, this is 52.20. Since the both are in same direction, so let us take this one as 52.20. Okay, now and here we have one force. This is 100 kilonewtons, and that too, this is 3 meters, 3 meter, and this is 2 meters.
Sir, sir, excuse me, sir.
Yes.
Sir, moment this one BA is in positive direction, we should go to the in anti-clockwise direction, sir. 52.2. The moment is 52.2 is in positive, no, sir.
Yes, both
Positive.
are positive.
No, sir. AB is 57 point minus, sir. It is negative.
AB is negative.
Yes.
Sir,
Huh?
yes, sir.
AB
50 minus 50.9.
minus 57.9. Okay. Okay. So if it is minus, then let us say, so okay. Tell me, your name is, I'm forgetting your name. Okay. If so, what you want? You want this to be anti-clockwise or clockwise?
Anti-clockwise, sir.
This is anti-clockwise. Okay. So let me change this one. So let me erase this one. Okay, this is A. This is anti-clockwise. This one is clock. This one is clockwise. You are saying, or anti-clockwise? This one also.
Clockwise, sir.
This is clockwise. So, but this the direction of the same is in two are in same direction.
No, sir. It should be in negative.
This should be in again. No, this BA MBA should be in anti-clockwise direction.
Yeah, no sir, clockwise only sir.
Why, sir? It is positive. No, it will be in clockwise direction only, sir.
That's right. Yes. So whatever you are saying, I'm doing that one. Okay. So, okay, this is one reaction. This is B. So, if we take moment across B equals to 0, or taking moment across B equals to 0, if I do that, what will be my equation? So let us say this is RAB, this is RBA, suppose. So RAB into 5, RAB into 5, then plus this 52.20, okay, then minus 57.9
minus 100 into 2.
and into, yes, minus 100 into 2 equals to 0. So please calculate how much is RAB.
Sir, 100 into 3, no, sir.
100, no, I'm taking
Oh,
moment
okay. We are
about
taking.
this one.
Okay. Okay, sir.
RA, I think 41.14.
41.14. So if RA is
RB
41.14,
58. RB 58.86.
Fy equals to 0, this implies RAB plus RBA equals to 100. This implies RBA equals to 100 minus 41.14. So how much it is coming?
58.86.
8.86 kilonewton. This is also in kilonewton. Okay. Now the next span is, let us take span BC. Okay, we will find out the reactions and we will keep this till now, till now only, and in the next class we will calculate the shear force and bending moment. Okay, for span BC. Okay, so here it is one reaction, here will be one reaction, this is B, this is C, here we have a UDL. Am I correct? Yes, it is correct, and the UDL is 20 kilonewton per meter, and this is RBC, this is RCB. And this one is 3 meters. Okay, so taking moment across C equals to 0, taking moment across C equals to 0. So, okay, how much is MBC? It is like this, 34.875, and this one is again 0, we have already calculated. So RBC into 3, then minus 34.875, then again minus 20 into what will be the value? Who can tell?
3, sir.
20 into
3.
3 equals to 0. This implies RBC equals to 20 into 3 plus 34.875 divided by 3. So please calculate. This implies RBC equals to how much kilonewton? 20 into 3. This is moment, na? 20 into 3 is WL square by 2 it is.
Yes, sir. Load.
So okay, so let me erase this one because this entire expression is wrong. So please calculate how much is RBC. So it will be 20 into 3 square divided by 6 minus 34.87, sorry, plus 34.875 divided by 3. Please calculate how much is RBC. Govardhan, how much is RBC?
23.952, sir.
23.952. So this implies RCB equals to how much? RCB equals to 20 into
36.048.
okay, 36.048
048.
kilonewton. Okay, next one, span. Span BD or column BD, whatever you may write. Okay. Now, for this column BD, which moments we need to consider? Who can tell? Harshvardhan, which moments we need to consider?
MBD, sir.
Mm-hmm.
MBD.
MBD. Okay, so how much is MBD? Sorry, this is in this direction.
Minus 16.7.
Minus
MBD is minus 16.7, sir.
16.7.
Sir.
Okay. Okay. So if I take moment across B, okay. If I take moment across B, so here I will have HD and here one will be there. Okay. So taking moment across B, if I take moment across B, HD into 3 equal plus or it will be, sorry, minus 16.7 minus 8.415 equals to 0. This implies HD equals to 8.415 plus 16.7 divided by 3. So this implies HD will be how much? How much will be HD? HD will be, please calculate.
8.37. 8.37.
37 kilonewton. Any other forces are there we need to determine here?
46.84, sir. 16.
Hey, how it will be? So 8.415 plus 16.7 divided by 3.
Yes, sir.
Is it correct?
8.37, sir. Yes, sir.
8.37.
Yes, sir.
Okay. Okay. So please mark these values. Okay. In the next class, we will go for drawing the shear force and bending moment diagram for this problem. Okay. So I'm stopping the recording now.